Okay, so I was trying to organize this group vacation recently for just a few friends.
Oh, yeah. That is always a complete nightmare.
It really is.
Yeah.
I mean, you think the logistical headaches are just going to add up, but no, they literally multiply into pure chaos.
Right. Suddenly you have like 50 different group chats for 5 people.
Exactly.
Oh,
And honestly, that perfectly sets up the math concept we are looking at in today's deep dive.
okay.
But really quick, before we get into the sums and products, if you are dealing with your own logistical chaos, you should absolutely check out our sponsor, Embersilk.
Yeah, Embersilk is fantastic if you need help with AI training or like automation integration or even custom software development, they have you covered.
Right. You can uncover exactly where AI agents could make the most impact for your business or your personal life. Just head over to embersilk.com for all your AI needs. So anyway, back to the math, right?
Yeah, let's get into it.
Okay, let's unpack this. Imagine you have a handful of numbers. If you pair them all up and add them together, you make one pile of
Yeah,
results.
your sum pile.
Exactly. And then you take those same original numbers, multiply every possible pair together, and make a second pile. Well, since 1976, mathematicians have sworn by this thing called the Erdo-Cemmerati Conjecture, which basically says no matter what numbers you pick, at least one of those two piles must grow massively huge.
Yeah, like nearly the square of the original set size. We just assumed they couldn't both stay small.
Right. But today we are looking at a groundbreaking paper published literally yesterday, May 27th, 2026. It's by Bloom, Solomon Shilkrout, and Zelazoff. And they just proved that 50-year-old rule completely false over real numbers.
It is wild. What's so fascinating here is that they proved both piles can actually stay relatively small. They constructed these arbitrarily large, finite sets where both the sum and product sets are just strictly bounded.
Which is mind-blowing. For you listening, is basically like throwing a spark into a room full of gasoline and, well, nothing explodes.
Exactly. The math just calmly stays put, which completely upends our entire understanding of additive combinatorics.
But wait, here's where it gets really interesting to me. How do you hide so many sums and products in an unexpectedly small space? I mean, did they just cherry pick trickier fractions to make the set smaller?
Well, if we connect this to the bigger picture, they didn't just pick weird numbers on a normal flat number line. They used these things called totally real algebraic number fields of growing degrees.
Okay, wait, slow down. Totally real algebraic number fields. Can we get a plain English translation of what that actually looks like?
Fair enough, yeah. So instead of a flat line, imagine pulling those numbers out into a high-dimensional grid or like a lattice. And in this space, they created an additive box of algebraic integers.
Oh, okay, so the rigid geometry of that grid keeps the addition neat and contained right.
Precisely. Adding coordinates on a uniform grid just predictably moves you to another point on that exact same grid.
Okay, that makes sense.
But the real trick is the second structure they made. It's a multiplicative box made of units.
Wait, what makes a unit special enough to stop multiplication from just exploding outward?
So think about the number 1 or negative 1. You can multiply them together forever, and the result never gets bigger, right?
Oh, right, it just cycles back and forth.
Exactly. In these high-dimensional grids, units act just like that. They perfectly overlap with the additive box, so everything just bounces around inside a fixed boundary.
Oh, wow. So what does this all mean for how we solve problems now? I mean, figuring out those overlapping boxes sounds insanely complex. Didn't AI just crunch the numbers for them?
Well, this raises an important question about how we do math now. They were actually inspired by OpenAI's recent unit distance counterexample.
Oh, I remember reading about that.
Yeah, and they even used GPT-5.5 Pro as a sounding board while brainstorming, but the actual incredibly elegant proof was entirely human-generated.
Wait, really? So human intuition actually cracked the geometry?
Yeah, they just used AI to bounce ideas around. The heavy lifting was all human.
That is just so incredibly inspiring, honestly. I mean, it proves that human ingenuity paired with AI as a creative sounding board is literally more powerful than ever.
Absolutely. It's a beautiful synergy.
Seriously, if we can shatter a half-century-old mathematical mystery today, just imagine what wonders of the universe you and humanity will unlock tomorrow. It really makes you optimistic about what we can solve next.
It really does. There are so many breakthroughs just waiting to be found.
Well, if you enjoyed this deep dive with us, please subscribe to the show. Hey, and leave us a 5-star review if you can. It really does help get the word out.
Thanks for tuning in, everyone.